All right. So,
First class ever had to do anything like that.
is that right? Well, I enjoy using them.
Cool.
Yeah.
It takes quite a fair bit of work to put them together. Okay, so keeping in mind position time velocities, let's talk about three types of velocities: constant velocity, average velocity, and instantaneous velocity. Let's begin. So you're driving down a highway and you notice that it takes equal intervals of time to travel between hydropoles. The hydropoles are likely probably, I honestly don't know. Anyone got a parent that works for hydro? Find out how far apart the poles are from me, would you? I'm going to guess like 75 meters, but I don't know. It takes equal intervals of time to travel between hydropoles. This is an indication that you are traveling at constant velocity, meaning that the speed is the same and so is the direction. The formula for determining constant velocity is V bar equals D over T, and no doubt you saw that in grade 10, right? Hands up if you saw that in grade 10. Excellent. I hope so. Anyways, right? Where V is the velocity in meters per second, kilometers an hour, and so on. D is displacement in meters, kilometers, and T is time intervals of seconds or hours. Notice, please, that there is a V bar. There's a bar over the V. Okay, and I'll get more into that in a little bit. Note that since displacement is either positive or negative, velocity will have the same directional notation. The similarity in sign for both velocity and displacement occurs because time interval is always positive. I.e., in English, to the right is positive for both displacement and velocity. To the left is negative, right? Just a refresher. Let's start by doing a practice one, I guess. Note, there it is there, right? The positive and negative. What is the constant velocity of an airplane that flies 602 meters east in 2.5 seconds? Express your answer in meters per second and kilometers per hour. Let's do the first one together. You know already that I want you to write the formula. At least I think you do. Okay? It's also a really, really good idea to line up the equal signs. The displacement is 602. The time is 2.5. And I'm standing here without a calculator. Well done. Is that the right answer?
Yeah.
240.8 meters per second. It wasn't that I was ignoring you. I just did. Well, I was ignoring you, but not because I was being mean. Because I was. Yeah. 240.8 meters per second. If you want that in kilometers an hour, you have to multiply by 3.6. And I get. Ooh, that's 867 kilometers per hour. Do you guys, let's just get this out of the way right now.
What?
867, right?
That's 36.
Is that to change meters per second?
Times by 36.
Times 3.6.
Oh.
Why? For what?
To go from meters per second to kilometers per hour is multiplied by 3.6. How many people have heard the expression significant figures or sig figs? What do you think of them, Kyle? Hang on, let me just turn this off so you can speak. In other words, as long as if I see the work and you have 866.4 and I got 867, we're good. Show me your work and we're good. Moving on. The tine on a tuning fork. You guys know what a tuning fork is?
No.
Right here. Anyone got perfect pitch in here?
It's perfect.
What is that? Yeah, you're right. No? It's 512 hertz.
I heard your voice at high.
You know you have to go down the octave.
Does that hurt when you run it?
It's going to hurt when I whack it on your head.
Other noises?
No, that's all it makes. Okay, this is a tuning fork. It's set up for a. No, the other letter. That's the manufacturer. It's set up for a C, right? Set up for 512 hertz. That's a tuning fork, and it vibrates and makes that sound. Okay. So the tine on a tuning fork moves 1 millimeter to the right in 4.0 times 10 to the minus 3 seconds. How many people have never seen scientific notation like that before? Don't know what this means. Never seen that.
Wait, no, I've seen that.
Never seen it.
I've seen it, it's pretty bad.
How many people would like a refresher on how that works?
You go negative,
Yeah, that's-
you go 3 spaces or something.
Okay, so let's talk about that.
What?
Okay, so what is the constant velocity of the tiny in meters per second? So first thing I have to do is convert millimeters to meters. Do you remember what the prefix milli means?
Millie.
Thousandth. So 1 millimeter is equal to 1/1000th of a meter, or 0.001. Right? How many decimal places? 1, 2, 3. How come? Because there's 3 zeros there. So 1 millimeter is 0.001 meters. And I want to know what the velocity is here. So V bar is equal to D over T. So 0.001 over 4 times 10 to the minus 3. Now what does that mean? 4 times 10 to the minus 3. Let's just do this on the side. Means 10 to the minus 3 means move the decimal place. 1, 2, 3 to the left. So instead of 4, I go 1, 2, 3 to the left, right? 0.004. Now, you don't need to know all that because you have a scientific calculator.
Oh my goodness.
Okay? One of my goals in life is to make sure that every member of the Canadian population knows how to use the scientific calculator, scientific number feature on here. It'll never happen, but that's okay. Okay, so on your calculator, I want you to all get it out. Don't be one of those Joe Cools back there that's saying, oh, I know how to do this, and then about 2 days from now, they'll be, I don't get this. You need a scientific calculator for physics class. Get one. Okay, so on your calculator, you're going to go 0.001. 0.001. And then you're going to go divide by, and then 4 times 10 to the minus 3. 0.001 divide by, and then you go, now you do not go times 10.
Oh my god.
Wow.
There's a button on your calculator that either has EXP or EE on it. And then you're going to go 4 EXP minus 3. And your answer is?
Oh, it already has times 10 down there.
Yeah.
Holy crap.
0.25 meters per second. I'm going to take 2 minutes now and I'm going to wander around. I want you to all show me on your calculator that you know how to do that properly.
Hold on.
All right. Then I want you to try this one. Here's one to try. You should have lots of space. If you get it wrong, that's fine. We'll fix it. Electron travels at a constant velocity of 1.3 times 10 to the 5 meters per second. How much time is required for displacement of 1 meter? You're solving for T. You've got 30 seconds. Go. Okay, dear. 30 seconds is up.
Oh my gosh! Why are you going to so yeah, Russia! You're one.
How do you start something like this? Start with a formula. We've got velocity, we've got displacement, we've got time. What is our velocity?
There's no time.
What?
I see none.
I see 1 meter.
1.3 times 10 to the 5 is our velocity.
Okay.
We are solving for time, so I've got a displacement of 1 over t. How do you solve an equation like that when t is on the bottom?
Time's always
From math class. The t goes up there and that number goes down there. They switch spots, right? So t is 1 over 1.3 times 10 to the 5. Go ahead and type that in your calculator. I'll give you the answer in 8 seconds.
Hey!
0 divided by
So I'm going to go 1 divided by 1.3,
times 10.
not times 10,
Oh, but
just EXP, and I can't find it on this one. Where is it?
1 divided by 1.3 times
Calculator.
I know, where is it? Oh, there it is. It's kind of faded out. EXP to the 5, and I get
I got 1 million points.
0.000
why do you not
No.
10?
007692. And the question up front is, why do you not have to put the 10 in there? EXP means times 10 to the power of. That's what EXP means. Now, if you get that,
I see
a
that.
general sort of convention is if you have a number in scientific notation in the question,
Look at,
you should likely give the answer in scientific notation. Now, you could do this. You could go 1, 2, 3, 4, 5, 6,
or you can go.
or you could learn how to use your calculator to put it into scientific mode.
So just, I have it like right here already.
Yeah, some of you may have gone to scientific mode already. Some calculators are real easy to go, others are not. If you have
So then I just go 7.6.
If you have an SCI button, that will put it into scientific mode for you. If you have a piece of junk like this one, you have to go something like mode, or setup, or I don't know. It's hard to find. Well, that would be equal to
I put 7.69 to the power of negative.
1, 2, 3, 4, 5, 6. So it'd be 7.69 times 10 to the minus 6.
How do I know that?
Okay, well, how do you even get that? I function that and then nothing happens.
I'll make my rounds. Okay, here's another one to try to practice on. A spaceship travels at a uniform velocity of 3.2 times 10 to the 4 kilometers per hour for 2.7 days.
Do we have to convert
What
to
is the
hours?
displacement? Yes.
So 2.7 divided by
You got to convert from days to hours.
2.7 divided by what?
Lost my port privileges.
Wow.
You want to see it?
Yes, please. No, wait, hold on. Hold on. What the heck?
First, you got to do that part. You got to convert days to hours.
Oh.
64.8 hours. Okay, write the formula. V bar equals D over T. We know the velocity of 3.2 times 10 to the 4. We're solving for D. The time is 64.8, right? How do you get rid of divide by 64.8? Multiply both sides by 64.8. They cancel. Come on. So the displacement is 64.8 times 3.2 exp 4, and I get 2073600, or in scientific notation, 1, 2, 3, 4, 5, 6. 2.07 times 10 to the 6. One last one to try. One last one to try. Give it a whirl. A couple of things here. First of all, the velocity is in kilometers per hour. The distance is in meters. So Cole, you need to do one of two things. Either convert 200 meters to kilometers or convert 85 kilometers per hour to meters. Really your choice. I would point out that the question asks for seconds, so you probably need to convert to seconds. So of those two choices, which one is probably the best? Convert kilometers per hour to meters per second, or to convert 200 meters to kilometers? You want to be in meters per second, because this is already asking for you in seconds. So step one here is to take 85 and divide by 3.6. We're making it smaller. We're making it into meters and seconds. So 85 divided by 3.6. 23.6 meters per second. And now what? Step 2 is put your phone away, and then step 3 is write the formula. V bar is, write it right underneath the velocity, write the number that is the velocity, 23.6.
200 can divide by 2. What's the time?
That's what we're going to solve for. How many seconds? What is the displacement? 200. Solve for t. How do you solve when the unknown is on the bottom like that? They switch places. This 23.6 goes down here and the t goes up there. You should know that from math. P equals 200 divided by 23.6. I get 8.47, 8.5. 8.5 seconds.
That'd be the same if you converted it from meters to kilometers.
It would be, but then your answer would be in hours, and you'd have to figure out how many seconds that was. You'd get a really, really tiny number of hours, right? Possible, but a little more challenging.
Oh, yeah.
Let's talk about the actual formula V bar. What does the bar over top, the V mean, Dave? What does the bar over top mean? Like, what's so special about that bar? The bar itself actually means average. It's got to have a little arrowhead to be effective. You put a bar over anything and it means average. Okay? Now, because all of these questions were about constant velocity, if the velocity is constant, then the average is always the same, right? Throughout the entire trip. So we can use that formula. Now when we get to part 2, which is average velocity, can be determined 2 ways. One is by formula. With there I mean, do I have something here? It looks like I'm missing something. What do you guys have there? Does it say? Yeah, but you got something there, right? By formula, yeah. So I'm missing, I don't have this on my screen for some reason. Yeah. So average velocity can be found by formula. And then the second, or is there examples right away? Well, yeah, I know where this goes. Right, okay. So if you're asked to find average velocity, see in all of these questions, it was assumed that the object is moving at constant velocity. Right, all of these. Right? Uniform velocity. Uniform means constant rate. Now, these ones here we're talking about not constant velocity. We're talking about going slower, going faster, but average velocity, we're talking about the same formula. In fact, most people won't even recognize that it's different. Okay? Let me show you an easy one here, right? So 3.2 kilometers over, 45 minutes. Should I convert something here?
Seconds.
I got kilometers and I got minutes.
Oh, hours.
So 45 minutes would be? And please don't say 0.45. 0.75, right? You would have to take 45 minutes divided by 60 seconds or 0.75. So that gives me 3.2. Oh, 3.2 divided by 0.75. 4.23. The average velocity of this person riding the bike is 4.3 kilometers per hour. They're not going to be always going that speed. They're going to speed up and slow down. Maybe if there's up a hill or down a hill or against the wind or with the wind or stop for a snack or who knows.
I don't understand what's the difference between this and kilometers.
There is nothing. The only difference is that in all those other ones, Gage, that the velocity actually was constant. It stayed the same. Now it's not staying the same. But the calculation's exactly the same.
So pretty much it's like in the question it says speeding up.
Yeah.
Part of the average.
Well, if you're running for a long distance,
I want you to think about this one for a minute.
by the first lap of the thing,
Read that and then think about it for a second. It certainly seems harder because there's more numbers, right?
we assume it's hard, it doesn't mean it is.
Okay.
You go 30 kilometers.
Average velocity is displacement over time. But I've got more than one thing going on here. I got 30 kilometers east, and then I got 45 kilometers west, and then I got 10 kilometers east again. I need my total displacement. Add them all up. So can I just go 30 plus 45 plus 10? Notice that I asked a question, I didn't say that's what you do. Can you do that? You could if you don't care about being right or wrong. You shouldn't if you want it to be right. How come? 30 kilometers east is to the right, so that's positive. But 45 kilometers west is actually negative 45, isn't it?
Well, sure, adding all these negative ones.
And plus 10 to the east. So my overall displacement, 30 minus 45 is minus 5 plus 10, yeah. Minus 5 kilometers is my displacement.
Oh.
Kind of like that little graphy one there where it was like 2 steps forward and 1 step back, I think, right? Now, what's the total time? 15 minutes, 20 minutes, whoopsie, 7.5 minutes. 15 plus 20 is 35 plus 7. Total time, 42.5 minutes.
42. Oh, I got that.
You got kilometers, you got minutes. Do they sort of mix?
Yeah, no.
No,
Games with
not so much, right?
Games with
We should probably convert this one to hours. How do I convert 42.5 minutes to hours?
Divide.
45 minutes is easy.
Divide.
Divide by what?
3.6.
No. Divide by 60.
Oh. Oh, come on.
42.5 divided by 60 to get it into hours,
You're
right?
gonna rough the rest.
0.6892.
I got like 0.71. 0.71 hours. Now what?
This is what you
Divide it.
Yeah, now we divide, right? V bar equals d over t. Displacement minus 5. Time 0.71. Are you starting to see how the organization of your solutions is important?
Yes, very.
If you're one of those ones that's writing all over the place, scattered kind of thing, it's time you learn to organize your stuff, get it in order. 7.04,
We have 7.
is it minus? Yes, it is. Minus 7.04, and that's going to be actually kilometers, isn't it?
Kilometers.
Kilometers per hour.
I think English people say kilometers.
I don't know, they're weird.
Kilo.
So we can do the third one.
Go ahead, try the third one. I caution you, make sure you're using pencil. Try the third one. I caution you to use a pencil. Mistakes have been made here before.
No,
Or do it on the left-hand side and put the answer on the right-hand side. I'll give you, that one's going to take a few minutes, right? Try it. Unless I see this diagram, I'm afraid you've got it wrong. An orienteering athlete walks 1.2 kilometers east and then 0.8 kilometers north. So this is the overall displacement is that one. It's a vector question.
Yes, class.
Right there. So you made all this converting for nothing.
You didn't even do nothing.
That's how come I could tell right away, because if I don't see that triangle, I know you don't know it's a vector and it's wrong. So you have to do what? 1.2 and 0.8. The total displacement, my friends, is not 2. This person walked 2 kilometers, but their overall displacement is d squared equals 1.2 squared plus 0.8 squared, and then you figure out your value for displacement.
Here's 0.8, by the way.
This is right in the question then.
It still doesn't technically mean they're right. Because they just do time. Oh, yeah.
I would call it difficult.
I get 1.44. 1.44 kilometers is the total displacement. That's it. I don't need to look at it. Well, you need that diagram.
I didn't do it.
You might have been able to do that with a diagram, but I'm taking a wild guess you did. 1.44 is the total displacement. It is not the total distance traveled. Josh, what is the total distance traveled?
2.
2. What's the total time? 25 minutes plus 15, which is 40 minutes.
Okay, so that's far away.
40 divided by 60 is 0.67 hours. V equals D over T.
That's my last.
What'd you do?
So it should be 2.14925373.
There's your answer.
Whoa.
Oh, actually, I am wrong. I made a mistake. I haven't got a complete solution here. What is my error? I just realized. Well done. Because it's a velocity vector, Chandler's right, you need a angle. Opposite over adjacent, so 0.8 over 1.2. I've thrown a lot of information at you today.
You did.
I'm watching it.
So we're talking east,
One day I'll get
34 north. Okay? Why do you have to do this?
To find your displacement.
The total displacement depends on the direction, right? You got to add that vectors together, right? Mitch has declared that class is over. He slammed his book shut. Says he's done.
failed.